Hi, and welcome to the Managing Transactions with SqlModelMapper session. Following is a little disclaimer about this session. In this session, we will see how transactions work in SnapObjects, what is the data context, instantiating the data context for SQL Server, for Oracle, for PostgreSQL, and for ODBC, that is for SQL Anywhere support. And we'll take a look into the data context transaction APIs, that is SqlModelMapper transactions and SQL Executor transactions. Following is some background about myself, and a little background about the company. Let's now begin with how transactions work in SnapObjects. Now, there are two types of transactions in SnapObjects. Those are implicit and explicit transactions. The implicit transactions are done automatically by the data context object, which we'll see in a moment. They generally require only one call to the transaction object's SaveChanges method. Commit and rollback are done automatically to the CRUD or SQL operations. It uses the tracks methods of the SqlModelMapper object. And explicit transactions, on the other hand, can execute multiple SaveChanges calls, but a manual commit and/or rollback is required. Now, continuing with what is the data context. It is an object used to manage database connections and transactions. It is very similar to what we currently have in Power Builder with a SQL CA object. The data context object includes several APIs for functions available for use. The first one we'll look into is the Begin Transaction API. It creates a new transaction. It uses the underlying database, and it uses the default isolation level. Next, we'll look into the same overloaded API. The difference is that you set a specific isolation level with it. This one is very simple. It commits basically the current transaction from the database. And this one rolls back the transaction. Now, there are two ways to instantiate the data context. First, it can be done by dependency injection, or it can also be done by creating an instance manually. Following are examples of pseudocode that illustrate how to instantiate each different database type using the dependency injection method. You'll notice that the main difference is the use of the use SQL Server, use Oracle, use PostgreSQL, or use ODBC. Next, we can see an example of source code behind the manual instantiation of the data context. In this example, we're actually doing a begin transaction and a commit. And you'll notice that the main difference is that the database name comes first of the data context options and the data context itself. The data context performs the transaction API operations in a four-step process. First, it determines if the transaction is explicit or implicit. If the transaction already exists, then an instance of the SaveChanges method is already included in the explicit transaction. But if the transaction does not exist, it creates a new implicit transaction. Then it executes each tracked item one by one. It does so by generating the appropriate SQL statements to run. It executes any tracked actions. Any tracked items are executed in a single batch and become part of the transaction of step 1. The next step only applies for the implicit transactions. It decides whether to commit or roll back the transaction. Finally, it clears the list of all tracked items associated with a particular SaveChanges call. So let's take a look at the implicit transaction pseudocode. The first line tracks the insert operations of the department table. It doesn't execute the operations until we call the SaveChanges method. The next line tracks the update operations of the employee table and applies a change to it, again without executing it yet. Then we can see an example of tracking embedded SQL statements. Finally, this is how we actually let the transaction to commit rollback any operation. Now let's take a look at the explicit transaction pseudocode. We start by beginning the transaction. We will use a try-catch for exception handling. Now we can see here how to execute embedded SQL statements directly. Then we can also track, insert, and delete SQL statements or any other type of tracking we might want, and add them to the transaction pool. Then, if nothing went wrong, we commit the transaction manually. Otherwise, we do a rollback.